We were talking about differentials. Because how would I normally write this? D by dx x squared is 2x, right?
Yeah.
Alright, so that must mean dx squared is 2x dx. No big deal. We've done that before. So this would have actually looked like this. It would have actually looked like 2x cosine x squared dx. So this is what I keep talking about. We're developing a more formal way to do that thing I keep talking about informally. If I want to integrate this, since it's got a function inside, it's got to have that function's derivative in there also. Does that make sense? Because what would I have to do to this if I took this guy's derivative? Chain rule. So the chain rule piece has to be there for this to work. And it is there. I kind of built it to be that way, but oh. Right? So now I can do this u thing backwards. What's the inside function here? What's inside something? Yeah, 2x is not inside. I can move around. X squared is stuck. It's inside, right? So if I said u is x squared, so that's why it's called u substitution. I'm going to substitute the inner function with u. What would du be? 2x dx. Stay with me. If some of you guys I know have seen this kind of thing before, and you're all like, well, that's what the hell he's been getting to. Good Lord, it takes him a while. So watch this. It's kind of cool. Again, because I dare to try to get you to understand why the hell it works. If u is x squared, du is 2x dx. Do I see all those pieces in here? If I don't, I'm either screwed or I got to adjust the number. Numbers I don't give a shit about. Numbers I can work with. We'll do a slightly harder one and show you the coefficients. I don't care. I can make them do whatever I want them to. You'll see what I mean. The x pieces, if they're not there, I'm shit out of luck. Do I see 2x dx?
Yeah.
All day. There's 2x dx. Do I see x squared? Of course, that's what got me started, right? So how can I rewrite this then? This equals the integral cosine of
u
du. I love it. And that's easy. So I made a kind of disgusting looking thing look much better. That is kind of gross. That looks a hell of a lot better. That looks easy. What is this?
Sine.
Of course it is. We know that for what? Sine of u, but what's u?
U is x squared.
Sine x squared. As long as you bring back in. So u is like the middleman. U makes things look better. I love the grammar. I want my dean to walk by. U makes things look better. Me no grammar, yes. So integral cosine, that looks a lot better than it did. Because by doing this, you preserve the form this is in. This is in the form cosine of something times its derivative. That's the form it's in. So I didn't change the form, I just made it look better.
So like you would do, so like if you were given the integral of 2x cosine x squared, you would try to change it into the cosine sine.
Yeah, you could use u sub to attack it. Exactly. So let's do another one. You okay? What's up?
I'll hold my question to me.
Okay, all right. I'll take my question off the air. Okay. So let's see. What about?
So I got lost on what was proof and what was the actual procedure of figuring out.
I understand. It's my fault. It's a new attempt. It's weird to try to introduce this idea. It's a relatively simple process, but it's weird to see why it works. It kind of feels like we're cheating a little bit. And some teachers teach us in a way that's a little too loose. So I'm going to show you what I don't want to see from you. And it's not because I'm an asshole. I am an asshole, but it's not a symptom of that. It's me trying to save you from yourself, from your future self. Good Lord, man. My students make so many mistakes when they learn this a certain way. Let me see. Oh, wait a minute. What do I want to say here?
Is that a 5 or a...
Let's make it 6. How's that? Yummy! So that really, I would never have given you this until we learned u sub. So now you start to see, I gave you relatively easier things to see that the derivative is there. Okay, I can work this backwards. I can see how this works. That is kind of gross, exceptionally gross. What you look for is there an inside function? So this feels like when we learn chain rule. Chain rule is all about the inside gets a turn. You identify the inside function. This is integral's answer to chain rule is this. So what is the inside function? Yeah, that's very obvious. This is the inside function. Sometimes it won't be as obvious, so we'll have to do some examples like that. But let u equal your inside function. And then what's du?
2x plus 3 dx.
So your whole purpose when u sub is you want to replace all your x stuff with u stuff and replace your dx with du somehow, right? So I got this, obviously. That's what got me started. So I can put a u in here. Do I have this?
Yeah,
You do. You just have what's wrong? So you just take 2 out. Yes, sir.
Could you have multiplied the du by 2 and then also multiplied the 2x plus 3 dx by
That's getting into the troublesome area. Some teachers teach people to solve for dx, sort of. This wouldn't really help you because you don't... Yeah, well, I mean, if you did this, then you would have, instead of taking the 2 out, you would have just put the 2 with the dx. Well, even that wouldn't work. You would replace, so you could replace this with 2 du. That would still work, and the 2 would still eventually come out. Yeah, so that would work. I'm okay with it. It's when you start solving for dx, that's the problem. If you ever have somebody showing you solve for the dx, it seems like it makes it easier, and your guys are like, I'm sure it does, because Jeff, you make everything hard. But when you do that, you start to believe you can do more than you can. I could always do this. Yay, I just have to get dx. I could always solve for dx. I just pull this shit down. Everything works. No, good God. I start getting students doing things completely wrong because they think they can do more than they really can. You got to use different procedures sometimes. That doesn't always work. U sub is the first thing you learn beyond normal integration. How many things you learn about that? A lot more after that. Well, if you do that, you feel like you can do everything this way. No, so not. So how do you know this is going to work? When you can replace all your x stuff with u stuff. If there's any x stuff left over, either it doesn't work that way or you made a mistake. You need it to be completely in terms of u now. So what's 2x plus 3 dx? Du. So all that becomes du. And this is going to be the square root of u. So u to the 1/2. That's easy. Look at it. That mess is that. That's awesome. That's too nice to believe. But it's true. It's too bad. I don't know. Do you guys see that? 2x plus 3 dx is what? Let me take those out. 2x plus 3 dx is du. So I replace that with du. Square root of this is square root of u. Bam. 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 Yes, Emerald math. Bam. So what is this integral?
2.
Yeah, because it'll become u to the 3/2, and then times the reciprocal, I like it, plus c, so it's really 2, so it's 4/3. What's u?
X squared plus 3x.
X squared plus 3x. 2 to the 3/2. So if you took this guy's derivative, you would get this, right? That's how you check yourself. If you took this guy's derivative, you have to get this because the integral of this is this, right? I mean, that's math has got to be able to go both ways. Yes.
You only could substitute u if you see part of the derivatives in it, right?
If it looks like the result of a chain rule. You see how there's an inside function and there's the leftovers outside. It looks like u sub might work. So I always tell students, try u sub first. And if it doesn't work, then you have to try something else you learn in Calc 2. All right, I got 2 minutes left. Let's do one more here. Oh, yeah, I like this one. Here we go. Wood shelf. Let's just do this here. So if you can't identify an inside function, you say, is there a function in there that is the derivative of another piece of something that's in there? Yes, there is. What would you make u because its derivative is in there? Yeah, if I make u ln x, its derivative is
1 over x.
and it's in there, 1 over x. So let me rewrite this. I haven't done this yet, but let me for the benefit. So I got 1 over ln x, 1 over x dx. Is everybody cool with that? Just breaking it up? It's the same damn thing, right?
Yeah.
So all I did was I collected all this, and what is 1 over x dx? Du. And what's ln x? Ln x is u. Ln x is u. It's in you. No. And what's the integral of 1 over u? Ln of absolute value of u. And what was u? Ln x. So ln of x. Kabam. What? So this is what I meant earlier when I said you can't always identify an inside function. So then you secondarily think, do I see a function that is the derivative of some other piece of this thing? Yes, 1 over x is the derivative of that. Okay, make that u, because there's its du. Aw. That's when, I said this some other form. That's when u sub works. So let me give you this handout that I forgot I had until just now. It's got a couple of examples. We still have to talk about part B on this handout. You guys ever seen those videos about the guy in Rust? You heard of Rust? Yeah. You've seen those videos, the English, he's, I'll explain. Planet Rust.
Yeah.
Planet Rust, yeah. So it sounds like
Thank you.
Sure.
Yeah,